Okay, rolling on in chapter 5, section 5.3, solving multi-step inequalities. So we've got compound inequalities. It's a lot like solving equations. We're going to solve linear inequalities involving more than an operation, including the distributive properties. So it's kind of like we're throwing everything at you like we did with equations, only doing so now with inequalities. So our checklist, number one, just like on equations, you're going to see it's going to be the same thing. Use the distributive property to remove any grouping symbols if needed. So if you see parentheses or anything like that, or parentheses, brackets, any other grouping, then use the distributive property to take care of that. The second thing here, combine any like terms on either side of the inequality. So just like an equation, if they're like terms on each side, then we can combine those. So numbers can be combined on the same side. Variables can be combined on the same side. Once you have to go across the inequality symbol, well, then you can't combine them and you have to use algebra. But if it's on the same side, we can check to see if we can combine and go ahead and do it there. And then, like I said, if it's on the opposite side of the inequality, just like an equation, opposite side of the equal sign in an equation, then we're going to have to use inverse operations, doing the opposite. So add or subtract to start isolating the variable. That's the number one thing. And then we want to multiply or divide to isolate the variable and get the variable by itself. And again, just remember, again, I can't say it enough, these are just inverse operations. It's just what we've been doing with solving equations. You're just doing the opposite. Okay? And over here, the other thing we want to make sure is that we just make sure we star this part here, that we make sure that we flip the inequality if you multiply or divide by a negative number. That's important. So everything is the same as equations. Just remember that we got to flip the inequality symbol if you multiply or divide by a negative. And then the last thing here is just to be sure that we have the variable isolated and positive on one side of the inequality. That should be your final answer, should have a positive variable on one side of the inequality. Okay, so let's do a couple practice problems here. Let's look at number 3 down here. Okay, the first thing we're going to look at, there's no parentheses, so don't have to do any distributing, but we've got an x plus 7 over 3 is greater than negative 4. So we've got this weird looking fraction. So let's try to get rid of that to simplify it. So we know how to do that. If we go ahead and multiply this by 3, then we have to do it on both sides. So we do that by 3 on both sides. Well, on the left-hand side, we know that's going to cancel it out. We're just going to be left with x plus 7, because these will cancel. And then we're not doing anything with the inequality just yet. And like I said, you can always make that little line if you feel like it, just to keep things in order on the left and the right side. I'm sorry. Let's draw it here. Let's just erase and draw it here. That way I can keep it on there a little bit better. Right through there, good. So now we've got x plus 7 on the left-hand side, and on the right-hand side we've got negative 4 times a 3, which is going to give us a negative 12. And then in the middle we've got our inequality sign here, right? Tough because they look like a 7 to begin with. But now we know that to solve this, all we have to do is add 7, or excuse me, subtract 7 to both sides. We know on the left-hand side that's going to cancel out, and we'll be left with x. On the right-hand side, negative 12 and negative 7 make a negative 19. And we didn't multiply or divide by a negative, so our inequality is going to stay the same there. The symbol is going to stay the same. Now, if we were to, it does say to check the solution if needed. Okay, that check just means we solved the inequality. We already did that. To check if needed, it just means let's pick any number that's greater than negative 19. So let's say negative 18. And if we just plugged in a negative 18 in here, okay, we know negative 18 is greater than negative 19. And just to check our answer to see, put it back in the original. Well, negative 18 plus 7 is, what's that, negative 11 over 3. Negative 11 over 3, which is a negative 3 2/3, which that is greater than a negative 4. So that does check out. So that's the checking part. And now the graphing part, which we've done before. The graphing part's fairly simple. We're just going to draw a little number line again. I'm going to put my negative 19 here. And just remember that when I do this, I got to make sure my negative 18's here, my negative 17's here. Then go negative 20, negative 21. Make sure I put them in the right order. And then we have an open circle or a closed circle. In this case, we've got just the greater than sign. Greater than, less than, no equal to. So it's going to be open circle at 19. And then we're graphing this way, all the numbers that are greater. All the numbers that are greater than. Okay, so that's all we have to do there. Let's look at number 4, because number 4 has a little bit more action to it, has some more stuff like a parentheses. So let's look at this one. All right, so the first thing we've got to do is we've got to distribute on the left-hand side. We've got to get rid of this grouping symbol. So 4 times 3t, I know is 12t. 4 times negative 5 is a negative 20. I'm just going to draw my line here just to help us. On the right-hand side, nothing has changed, so it's 8t. Whoops, it goes back to blue here. 8t plus 3. And then nothing has been done with the inequality sign, so it stays the same. Okay, do we have any like terms? We don't have any like terms. We take a look on the left side. This is a t and a negative 20. We can't do anything there. We've got a t and a 3. We can't do anything there. So we can't combine any like terms. So we can start trying to solve this thing, start trying to isolate the variable. Well, now we got variables on both sides. So my goal is always to try and get the variable on one side. So I'm going to go ahead and subtract 8t from each side. That way, I know over here on the right-hand side that cancels out, and I'm going to be just left with a 3. And on the left-hand side, I know 12t minus 8t is 4t, and I've got a minus 20, just like when we solved the equations. Again, I can bring my inequality symbol down. Haven't had to change anything yet. Now, again, I've got variables on the left. I want to get my numbers over to the right then. So I'm going to add a 20 to both sides. Add 20 to both sides. I know over here that's going to cancel this out. So I'm left with just 4t. On the right-hand side, I've got 3 plus 20 is 23. Didn't have to do any flipping there. And then finally, I'm going to divide by 4. That's my last step, is I'm going to divide by 4 on both sides, just like solving equations. Since 4 is positive, I don't have to change the inequality sign, and I get, what, about 5.75 here would be my final solution. If I were to check, I would plug in a number that was greater than 5.75 into my original equation and see if it works out. And then finally, my graph, I think we're good on that. I think we've done a lot of those examples. Okay, so let's move on to the next thing. Other possible solutions. We talked about having a variable on one side, positive variable as your final answer. But what if you don't? What if the variables cancel each other out? So just like in equations, we've got situations here in inequalities that this could happen. All real numbers. So remember when we, I don't know why my sign's not working here. I can draw it in for you. Remember, all real numbers is that sign. Looks better here, whatever. But this is when you solve the inequality and you get a true statement. So again, now you're not going to have any variables, no variables. Your variables cancel each other out. No variables. And you get a true statement. So when we dealt with equations, we had like negative 2 equals a negative 2 here. Or but in the case of an inequality, it might be something like 0 is greater than negative 3. Well, those are true. It's a true statement. So in that case, your solution will be all real. So any number you choose for x will make the inequality true. So like I mentioned before, with equations we did, negative 2 equals negative 2. Inequalities, it means anything we plugged in here would be true. We have a true statement here. So the answer then would be all reals. Empty set or no solution. Remember, that's this thing here. Okay? This basically means any number you choose for x will never make the inequality true. So there's these situations. Again, we get a false statement. We solve the inequality and get a false statement. It would never be true. So with equations, remember our example here for equations was 5 equals 8. Well, we know that was a false statement. That was false. So with inequalities, it might be something like 2 is less than 1. Well, no, it's not. That's false. So our answer there would be no solution. If you end up getting that. Again, the key is no variables. So somewhere along the line, your variables got canceled out. And once they got canceled out, well then we know we're either going to have all reals or empty set as our answer. Okay, let's go ahead and do.
Can you put Jolo to the main office, please?
Let's go number 10 here. Just because it has a lot of action to it, it's got a lot of stuff, and got some parentheses, things to work with. So let's go ahead and work on that one. Okay, so the first thing we're going to do here is we're going to make sure that we get rid of those groupings. And so we're going to go ahead and distribute here on the left-hand side. If I want to make this a plus negative action, I can. So that when I distribute, I end up going negative 3 times b, and negative 3 times negative 2. That just keeps it simple to make sure that we're understanding that I've got a negative that I got to deal with here. Okay, I'm going to draw my line here. So when I do that, nothing happened with this 3 first. Go back to blue. Nothing happened with that first 3. And here when I distribute, I got negative 3b, and then I've got a positive 6, because negative 3 times negative 2 is a positive 6. On the right-hand side, I still have my 13. Nothing happened with my 13. And now I can do this again, make it a plus minus. That way I know negative 3 times b is negative 3b. Negative 3 times negative 6 is a positive 18. Okay? And then I've got my inequality symbol in the middle. All right, so now the second part. Let's look along our left and right sides. Do we have like terms? Well, I've got a 3, I've got a negative 3b, and I've got a 6. So I do have 2 terms that I can combine here. The 3 and the 6 would make it a positive 9. And then the negative 3b is just going to come along with as a negative 3b. On the right-hand side, do I have some things I can combine? I sure do. I have a 13 here, and I have an 18 here. That's going to make a positive 31. And then I've got a negative 3b here as well. And then I can bring down my inequality sign. The last thing I'd have to do here is then, now I'm going to try to get variables on one side and numbers on the other. So when I do that, if I add 3b to both sides, well, then I'm going to be in an interesting situation. Let's look at the right side. I know these cancel each other out, and I've got a 31. And on the left-hand side, what happens over there? Well, they also cancel each other out. So now my variables are gone. I'm left with a 9, and I've got 9 is less than 31. Well, is 9 less than 31? Yes, that's a true statement. So it's a true statement, meaning that my answer would be all reals. All reals. Okay? Again, just to remember, if we do that, we have no variables in this situation because the variables canceled out. So if you have no variables, you're either going to have all reals if it's a true statement, or you're going to have no solution if it's a false statement. In this case, it's a true statement, so it's all reals. Okay? That brings us to the end here. So our first thing with lesson summary, when we skip some problems, there's always practice problems. And I know we also didn't do any problems where we had to flip the inequality, so we want to work on some of those. Lesson summary, how do you know if an inequality has no solution or all reals as a solution? We just talked about that. That should be fresh in your mind. And then we're going to solve this inequality here. Notice you got some groupings. You might have to combine like terms. And we'll see if we have to do any flipping of the sign of the inequality. We didn't do any of those, so we've got tons of practice problems which you can work on. But that is it for section 5.3. And we will see you tomorrow.